fundamental counting principle is a way for us to figure out how many different ways something can happen, or how many different ways things can be arranged or ordered or organized. So this is what the fundamental counting principle technically says. It says the number of ways in which a series of successive things occur is found by multiplying the number of ways in which each thing can occur. Now, I know that probably doesn't make a whole lot of sense, but I promise as you look at some examples, it'll start to become clear. So let's just say, for example, to give us an idea, that you're trying to get dressed in the morning and you have 2 hats to choose from, you have 3 shirts to choose from, and then 2 pairs of jeans to choose from. Alright, so let's just draw out how this might work. So let's say my drawing's not real good, but we'll go with it. Oh wow, it's a terrible hat. It's better in my head. Alright, we'll say that's a red hat. That's a blue hat. And then we've got 3 different shirts we can wear. So with the red hat, I can wear any one of my 3 shirts. My black shirt, my red shirt, or my blue shirt. Okay, and then we can do the same thing with the blue hat. Okay, so the blue hat could be any one of those 3. Alright, now we need to take into account the jeans. So let's say we could wear either our blue jeans or our black jeans. My jeans are getting worse as we go along, sorry. Alright, so that's all the black jeans, and then let's say we also have blue jeans. Whew. Sorry for the artistry here, or lack of. But hopefully this will pay off when you see how this works out. Alright. So those are all the different kind of combinations you could have. So just to illustrate here, you could choose the red hat, the blue shirt, and the black jeans. So that would be one combination. So ultimately, there are going to be a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities. Because you could follow any one of those paths to get there. It's like the first path goes from red hat to black shirt to black pants. The second one is from red hat to black shirt to blue pants, and so on. So each one of those at the bottom represents a different path we could take, or different choice of outfit we could take. Now you could obviously do one of these trees every single time, but if you're as poor an artist as me, you can see that could take a long time and not even look very pretty at the end. So it turns out that all you have to do is take these 3 numbers and multiply them together. 2 times 3 is 6, times 2 is 12. And that's the fundamental counting principle. It's pretty straightforward. I'm going to give you a few more examples just to give you an idea how this works. Let's say you're planning part of your semester in college and you need to take a math class, and there are 8 math classes you could take. Could just be 8 different sections or 8 different types, either way. And let's say there are 5 English classes you could possibly take. So you're choosing from one of these. So you're choosing 1 out of the 5. And then you're choosing 1 out of 4 history classes. Okay, so you're only going to choose 1 math, 1 English, and 1 history. But the idea is that you have 8 different math choices you could make, 5 different English choices you could make, and 4 different history choices you could make. So the question is, how many different ways could you arrange your schedule? Well, assuming none of these conflict with each other, then you would have 8 times 5 times 4, or 160 different possible schedules. So you actually have a whole lot of choices, which, I mean, it's pretty cool when you think about it. 8 plus 5 plus 4, that's only 17 different classes you're choosing from, but they can be arranged in 160 different orders, or 160 ways. So that would be the way you could choose some classes. Okay, so let's try another scenario. Let's say you're taking a multiple choice test that has 10 questions. So 10 question, multiple choice test. And there are 4 choices in each question. So A, B, C, D. How many different ways could you answer this test? How many different ways can you answer the test? Well, how many different ways can you answer question number 1? 4. How many different ways can you answer question number 2? 4. 3, 4, 4, 4. So all 10 of them, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of them could be answered 4 different ways, and there are 10 questions. So you just do 4 to the 10th power, basically, which turns out to be 1,048,576. So there are 1,048,576 different ways you could possibly answer this multiple choice test. Alright, last example. Telephone numbers in the U.S. Okay, you know our general area code is, well, let me just write it this way. Area code has 1, 2, 3 slots, and then your normal phone number is 1, 2, 3, dash 1, 2, 3, 4. So there's a total of 10 digits, and at least in our area, we always have to do the area code, even on local lines. It actually turns out that the way the phone company has arranged it, or maybe it's the way the government arranged it when they set this up, I'm not sure, these two cannot have a 0 or a 1 in them. Okay? These two cannot have a 0 or a 1. All the others can have any number you want, but these two cannot have a 0 or a 1. So that means that you can only have, for this one right here, 2, 3, 4, 5, 6, 7, 8, 9. So there's only 8 possibilities there. So I'm going to write 8 right here. Now I'm not saying the phone number is 8, I'm saying there's 8 different things that could go there. Okay, well the next spot actually has 10 different things because it has 1 through 9 and 0. So there are 10 possibilities there. There are 10 possibilities here. Now again, this one is one of the ones that's not allowed to be a 0 or a 1, so it only has 8 possibilities, but all the rest have 10. So all you have to do to figure out the total number of possible phone numbers for the U.S. is multiply those together. So 8 times 10 times 10 times 8 times 10 times 10 times 10 times 10 times 10 times 10. And it turns out you have 6.4 billion possibilities. 6.4 billion possibilities. So we should be covered, at least for a while. Because there's only about 7 or 8 billion people in the whole world, so if this is just how to dial numbers in the US, we should be covered. Alright, if you want any practice with this kind of stuff, if you look in your books on page 985, anything from, say, 21 through 32 would give you a good practice.